All right. One dash one. Polynomial functions. Nomial just means it has some terms in it. Poly meaning many. You see sometimes you have just a monomial, just one term. Or we've done binomials, trinomials, things like that. You spent a lot of time factoring trinomials in Algebra 2, and even binomials for that matter. Polynomial in one variable simply states that there's just one variable in there. That's pretty straightforward. It actually tells you what it should have. There's a key, though. It can have no negative exponents or variables in the denominator. Believe it or not, if you remember, that's really saying the same thing. Because when we had variables in the denominator, we could move them up and make them unhappy, make them negative. Okay, so no negative exponents or variables in the denominator. That's a no-no. So basically, let's take a look at number one there. As you look at that, is that a polynomial? Does it have terms? Basically, is all you have to look at. And do they all have the same variable? And then sometimes people say no, because they look at the one term that doesn't have a variable on it, which is the -1. But could I somehow put a variable on there and not change the problem? Yeah, I could put a -1t to the 0 power, right? Because this is really t to the first. So could they really all have it? They can. Now, if there was a s thrown in there on some of them and not on others, well, then we don't have just one variable. That's a little different. So yes, this one is a polynomial in one variable. The next question is asking then, because it says right here, if yes, then determine the degree of the polynomial. Well, if I were to just ask you the degree of that term right there, the 8t squared, what's the degree of that term? Well, it's 2. But what's the degree of the polynomial? It's really not all that harder. All you have to do is look at all the exponents and find out which one's the biggest. And as you look at those exponents, which one's the biggest? 3. So you would say yes. And seeing we said yes, we had to take a look at the degree of the polynomial. It is a third degree polynomial, or third degree, 3, whatever you want to say there, because it's the biggest. The trick there is they don't have to put the biggest exponent first. This one here is what they say, because this is t to the 0, they call this descending order because it goes 3, 2, 1, none. All right? They don't have to do that. Can you rearrange them? Well, sure. But they don't have to do that. So let's take a look. Again, is that a polynomial, number 2 now? Is that a polynomial in one variable? Yeah, it's just an x. Okay? Again, if there was something else in there, we might have a problem with that, but there isn't. So yeah, that's good. What's the degree? It's actually degree 5, because 5 is the highest power. The reason that you always have to look for that highest power is that it's going to become very important. It's basically going to tell you how many answers there are, okay, in a very short amount of time. Okay? So again, that's a polynomial in one variable. No big surprise there. I think it's pretty straightforward. This is called functional notation. If you read it, it would say find p of 3 and p of -2 for each of the functions. Well, you have to find some function that's been named p. Well, luckily in 3 and 4, both of the functions have been named p. And then they had an x there. And the x has been replaced with a 3, and then the x has been replaced with a -2. And that's basically what you do. You start writing it. That x, for this one, they want me to replace it with a 3. So you keep writing, and every time you see that x, you replace it with whatever they just wanted you to replace it with. So should I replace the 5 with a 3? No, it's just the 5. Leave it as a 5. Whenever I replace, I like to put parentheses. I'll show you why in a second. That x should be replaced by whatever they wanted me to replace it with, which is a 3. And then there's a plus 6. So basically, I just kept writing and replaced every x I saw with whatever they wanted me to do. So this one here, not much I can do there. The reason I like to put the parentheses is if you don't, it would look like a 53. Okay. The parenthesis reminds me that we have to do what there? You know, I have to multiply, right? And order of operations says to do that before I add. And so we take 5 times 3 is 15 plus 6. Now, some of you are looking at this p with the 3 on it and think that's 3p, like 3 times p. No, this is functional notation. It's saying put 3 into function p. You're going to leave that p of 3. You're not going to touch that. Just leave it. Can I do anything to the right side, though? Yes, I can. I can add those together, and I get 21. That's it. You do not divide by 3 here. Okay? That's why so often you've been told in algebra to put that coefficient in front if that's where it was supposed to be. If it's supposed to be 3p, you would put it in front. Okay? That's not what this is supposed to be. It's supposed to be p of 3. Now, I'm not done with number 3. I also have to do what according to the directions? P of negative 2. All right, so p of negative 2. So you go back to the original. There's a 5. Take that x, put in a negative 2. Oh, plus 6. Again, that's p of negative 2, not negative 2 times p. Big difference. Okay. So p of negative 2, just go along here. Again, you put the parentheses there because otherwise it might look like 5 minus 2 if you can put it in there. So this is a negative 10 plus 6. And p of negative 2 is positive or negative? Negative 4. Okay. Why don't you try number 4 right now on your own? Do both p of 3 and p of negative 2, please. All right, let's take a look. So first probably do p of 3, because that came first. You notice I gave you, I'd say, a substantially harder problem than the one that I did with you, just to see how you would do with the order of operations. And all the signs. A lot of subtraction here, a lot of substitution, so we got to make sure. So again, it's not 3 times p, it's saying p of 3. You might want to get used to saying it that way. So this very first term, we do 2, and then we got 3 to the third. Do you multiply first, exponents first? What do you got to do? Well, in this case, the first thing you should do is take 3 to the third. And 3 times 3 is 9, times another 3 is 27. That's 3 to the third, right? If you take 27 times 2 is 54. Now this minus, well, it's not in those parentheses. I'm not trying to square the negative. I'm trying to square the 3. So it's minus 9, minus, coincidentally, 9 plus 1. Any questions with how I came up with those numbers? Or why I did things in a certain order? No? All right. So p of 3, we do some calculation there. And what do you get? 37. He is correct. Everybody good? And I'll be honest, the one I was even more concerned about was p of negative 2. Because there's a whole lot more going on with p of negative 2. So you start writing. Well, we got a 2. Don't change that. It's a negative 2 that has to be taken to the, well, according to that, third power. Minus a negative 2 that has to be squared. Minus 3 times negative 2 plus 1. And so I chose this one because I knew there'd just be a ton of negatives everywhere. Would you try and cancel them? Some of them you can, some of them you can't. There's a whole lot of stuff going on. So let's talk about it. Same thing with this first term. I should take negative 2 and take it to the third power. But if you take a negative to the third power, does that end up negative or positive? Ends up negative. You take negative 2 times negative 2 is a positive 4, right? Times another negative 2 is negative 8. Negative 8 times 2 is negative 16. On this next one, can I do the whole add the opposite thing that you've been taught here with these two negatives that are sitting next to each other? Unfortunately, you can't. Because this negative 2 that's in the parentheses has to get taken to the second power first. That's the first thing you have to do. That's what order of operations tells you to do. So you take negative 2 to the second, which is negative 2 times negative 2 is a positive 4. But then there's this negative out here, so it makes it a negative 4. That's a very easy place to mess up on this one. Okay. How about these? It's a negative times a negative. Is there any power up there? No, so you don't have to worry about it. All right, so let's get rid of that. So that's a positive 6 plus 1. And we get p of negative 2. I think hopefully it's obvious that it's a negative number. Basically it's negative 20 and a plus 7. Negative 13. Questions on any of those? No? All right. Something that I skipped over, I was going to see if anybody mentioned it, is basically the difference between an even function and an odd function. Okay. For now, what we'll say with even versus odd, like it says there, odd functions have graphs that end in different directions. So odds have functions that end in different directions. For example, then, one of these is, when I say ending, one of these is going down at the left and up on the right. Are those going in different directions? Yeah, one's going up, one's going down. That's an odd function. Or if you really want to get silly, you can do that too. You could get in there and just do a bunch of these and then do that. Okay, that's an odd function in general. And then is it okay then to do kind of the other way and do that? Because that's kind of the opposite of what I've been doing, right? But are they still ending in different directions? Yeah, one's going up, one's going down. I would count those as being odd functions for now. We're going to give it a much more formal definition later. Well, even functions then are ending in the same direction. What's probably the most common of those? Parabola. There you go. Or that parabola could open down. And you saw a bunch of these, perhaps in Algebra 2. Those are ending in the same direction, right? Both going up. Okay, for now, we'll count those as even. Good enough definition for us for right now. Any questions on that? That's pretty straightforward as well. Yes, sir. It can be, yes. And for based on our definition, yes. The question there was, if you didn't hear, wouldn't a straight line count based on our definition so far? Yes. We will add to our definition. Good question. And this skill right here will prove incredibly important if you plan on going on to calculus. You will need to be able to do this and do it very well. Our function now has changed its name. Our function is now f. But before, we replaced it with, what, a 3 and a negative 2? That's what we replaced the x with. Now we're going to replace the x with more letters than there were before. Because right there, if we started with f of x, the x is going to get replaced by x plus h. So let's get started. Here's where the x was. Let's replace it with x plus h. And so you're going to go through this function, and every time you see an x, you're going to substitute in x plus h. So right there I saw one, and so I substituted. Here's an equal sign. Then there's an x. What should I replace it with? X plus h. And I actually like to put it in parentheses. It really doesn't matter for this problem, but I like to do it anyways. It gets me in a good habit. So basically, do you agree I've replaced that x then? That one's been replaced. This plus sign, well, plus. And the 2, does that get replaced? No, just write a 2. Can I do anything to x plus h plus 2? Can I simplify that in any way? Like, can I put the h and the 2 together or anything like that? No. That one's pretty well done. That's about all you can do. I mean, if you wanted to clean it up, in this case, you don't really need the parentheses. There you go. You can leave them in there, though. You just don't need them. This next problem, parentheses are going to be very important. Okay? In fact, we'll just do this one together. I don't think I have f of x on your notes. Make sure you add that in there. So basically, you can put it in front if you want. So we want f of x plus h. Okay, so wherever there was an x, I'm going to replace it with x plus h. So here we go. There's a 3. So write down a 3. And then there's an x. Right there. So replace it with x plus h. But what was being done to the previous x? It's being squared. So what do I have to do to x plus h? I have to square it. Okay, so this square just follows right down there. Then there's a plus and a 7. Is everybody okay if I erase problem number 5 over here, use it for workspace. I'd be good with that. That one wasn't too bad, right? Based on order of operations, what should I do first over there? Yes? Close. I have to square x plus h, which is a binomial. It has 2 terms, which means I have to take x plus h times x plus h for itself. And unfortunately, what that means is FOIL. Okay? Please realize that this number right here could potentially get bigger, which means then you have to take it times x plus h again, and perhaps again, and maybe even again. But let's just do it with squared. Well, first term times first term, so x times x, x squared. And then I have to take x times h, which is, yeah, xh. There's not much you can do there. It's kind of weird. That's okay. Then I got to take this x times that h. Well, that's another x h. And which terms have I left? Which one have I not multiplied? Yeah, h and h, which is h squared. Again, this is kind of scratch paper over here, because I can actually do something to what we have here. Those 2 terms that I put a squiggle underneath can be combined because they have the same variables. So it's x squared plus, there's one xh here, there's another xh over there, right? One of them here, one of them there. I have 2 of them. Are we all okay with how we FOILed or expanded x plus h squared? Is good? Okay. Is that the answer to my question? No, that's just part of it. That's basically that part of it, correct? So now we have to go put that back in there. All right. So f x plus h. And I'll do it kind of long. I'm sure some of you skipped through this. That's fine. 3. This x plus h squared, I can replace with that over there. Whoops. And then there is a plus 7. Don't forget about that. It can be very easy to forget about little stuff like that as you're going through these problems. We're almost there now. All we have to do, distribute the 3. 3x squared plus 6xh plus 3h squared plus 7 or plus 21? Why just 7? Yeah, the 3 is not part of that. It doesn't go to that, right? The 3 stops. It goes here, here, and there, but it does not go to the 7. So it is just plus 7. If I were you, somewhere off to the side of your notes, I would make a note that x plus h squared is this, so that when you see it again, you don't have to FOIL it out every time. You know, just off to the side, say that's what it is. You know, circle it or something like that on the top, or you know, make a note of it. You got plenty of room on that page. You know, just basically say, you know, x plus h squared like that, it comes out to be x squared plus 2xh plus h squared. Save you some time. Any questions?